The topic is understanding containers, pods, and deployments with respect to Kubernetes. The container is the smallest unit. It is a lightweight, standalone package that includes everything needed to run an application code, runtime, system tools, and libraries. So when we remember container, we remember Docker, where we had the concept of container that was really significant. So we would be building a container by the Docker image, and we would write the Docker file to build the Docker image. So that Docker file acts like a blueprint for the application to build, run, and container would be the application in itself. The role of the container is to ensure the application runs identically regardless of the environment, that is, developers, staging, or production. So what is the limitation in the container? It has no concept of networking or storage persistence on its own within a cluster. It simply executes the process. So we know that the container doesn't have persistence on its own, meaning if it is deleted, it doesn't have the capabilities of auto healing to get back the same container or other production grade benefits that is offered by Kubernetes. So if the container has some error or it faces some issues, and if the container gets deleted for some reason, it has some issues in starting and restarting of the container, it has a strong possibility of losing all its information and its data. That is the biggest drawback of container. So it doesn't have the benefits that Kubernetes offers, which is auto scaling, auto healing, and all those production grade. Also, other than running the Docker Compose in the concept of containers and Docker file, when we build a Docker image and when we run it, we would be specifying certain ports, exposing the ports while building and running the container image. So that is also a task to perform every time you build and run an image. That is to perform Docker run and perform certain flags and ports every time you build or run the container. Whereas when we perform pods or perform deployments, that is actual production grade benefits as well as efficiency, it doesn't have those issues or those limitations or those inefficient commands. That was about container. Now let's understand pod, which is the wrapper. In Kubernetes, we do not deploy containers, we deploy pods. Up is the smallest deployable unit and acts as a wrapper for one or more containers. So if Docker had the concept of containers, Kubernetes has the concept of pod, which is similar to container, but it is not exactly container. So we know that Docker container has certain commands to expose the port and then build it. In pods, that limitation is solved. Also, if a pod has more than one containers, that would also share the same local IP address and storage volumes, which is a bit better than the container. Although container has its own benefits and its own purpose, but the concept of pod is one level up the container. In Kubernetes, pod is the smallest deployable unit and acts as a wrapper for one or more containers. So what is the relationship? Containers inside a pod share the same local IP address and storage volumes. Pods are ephemeral in nature, that is, pods are temporary. If a pod fails, finishes its task, or the node it sits on reboots, the pod is deleted. A standalone pod cannot self-heal. If it dies, it does not restart itself. So pods are also temporary. Also, if a pod fails, it finishes its task, or the node it sits on reboots, the pod is deleted. Meaning it is not same as what containers would be doing, or what containers offers with respect to it getting deleted. It is not same. The pods that are getting deleted are the specific pods that would get deleted. That is the exact pod. Meaning if the pod is deleted, fails, or whatever that is mentioned on this ephemeral line, the near identical pod is created if we have specified replica set of more than one in the deployment file. Meaning if this statement was same as containers are temporary, if a container fails, finishes its task, or whatever reboots or the container is deleted, that would be considered as permanently deleted until we create a container manually again. But it is not same in Kubernetes. If we specify replica set of more than one, that is 2 or 3 for the pods, even if the pod fails, finishes tasks, or it gets reboots or is deleted, then near identical pod would be created. So it would not be the same pod in the sense of exact same, but it would be a near identical with same features and everything. Only thing would be it is a new pod. It is not same, but it is exactly same. Hope you get my point. Also, a pod stand alone cannot self-heal. If it dies, it does not restart itself. So this is very important point. We have been comparing pod versus container a lot, but we do not know the actual difference between pod, container, and deployment. A pod is near similar to the container if it does not have the concept of deployment. Meaning, if you only take the concept of pod and only a concept of container, it would have not much of difference other than you building a container by performing flags and ports, and you building a pod without it and only specifying that information inside the pod.yaml. Hope you get my point. It would be near same. So it would be if a pod created with this mindset without deployment that has replica set controller to have replicas for auto healing, then single pod YAML file would be same as Docker container. Deployment concept, that is deployment.yaml, makes a difference by letting users use the concept of controllers, that is replica set, for us to have more than one replicas or however replicas we want of a pod. So if that pod gets deleted, a new near identical pod is created. So that is the auto healing concept offered by the deployment.yaml, not exactly pod.yaml. Pod.yaml, if it is named pod.yaml with the replica set concept and you are saying this is also my deployment YAML, then it is true. But if you are saying you have a pod.yaml with no controller, that is replica set concept, then it is similar to container with it having flags or ports to run without you performing Docker run with the flagging of the ports. The pod cannot self-heal on itself. If it is inside the deployment YAML file that has controller, that is replica set, then it can self-heal. If it dies, the new near identical pod is created with respect to the specified replica set of the pods that we specify. That was about pod. Now let's understand the deployment, that is the controller. A deployment is a higher level object that manages pods. It defines the desired state of our application. The replica set. The deployment manages a replica set, which is the specific mechanism that monitors the number of running pods. Auto healing. If a pod is deleted or crashes, the deployment notices the discrepancy between the desired state, example 3 replicas, and the actual state 2 replicas, and automatically spins up a new pod. Rollouts and versioning. Deployments allows us to update our application version, rolling updates, or revert to a previous version rollbacks without downtime. So as mentioned, pod in itself cannot self-heal and perform the task that Kubernetes screams about. So deployment is a high-level object that offers those benefits to the pods. So it defines the desired state of our application. So it has a concept of replica set, that is a controller. While I explained the concept of controller and controller manager, that is in the architecture of Kubernetes. So controller is one of it, and there are multiple controllers in Kubernetes. One of them is the replica set. So a replica set is a controller that manages replica set, which is the specific mechanism that monitors the number of running pods. Meaning, if you specify 3 replicas in the replica set, and if our pod gets somewhat errors or whatever, and the actual state is 2 replicas, so the replica set and the deployment would communicate to the API server of the Kubernetes and it would spin up a new pod. Also, it offers rollouts and versioning as well. So that's the difference. Pod in a single concept without replica set in it and without a deployment file in it is similar to the container. If the pod gets deleted, it would be permanently deleted without auto healing. However, if the pod are specified inside a deployment YAML file with replica set controller and specifying certain replicas, then it would have the concept and the benefits of auto healing and rollouts and versioning. So that is the difference between containers, pods, and deployment. Now let's understand this table. Container management level is runtime. Key responsibility of container is to run the application code. Does it have self-healing? No. So pod has the management level of resource. Its key responsibility is to provide IP and storage to containers. Does it have self-healing on its own? No. Deployment management level is orchestration. The responsibility is to maintain the count and version of the pods. Does it have self-healing? Yes. So that is it for the video today. I hope the topic was simple and insightful. Thanks so much for watching. Have a good day. Bye.